Hello everyone. Today we will start a new topic, basic statistics. But before we start this topic, I wanna uh, go back to broadcasting here in the previous topic. So I just this example, because here actually we show one example how to do the broadcasting when we have two arrays that one of them has only one row. Okay, I want to show example where this has only one column. Okay, so here we have one column. So now the rule is applicable because here they are different in this axis, in the axis one or the second dimension. So the dimensions are different here, but one of them is one. So then the rule is applicable here and it's applicable here. Both of them are three. So broadcast will, so whatever the operation we are performing, it will take a place. Let me run this here. As you can see, this is the first 2D array, and this is the second 2D array, which has only one column. So now the addition and the multiplication, both of them have taken a place. So think of it conceptually that this row is replicated as many as this column is replicated as many as the number of columns in this one, and then the addition or the multiplication has been performed. Okay, or like this column is added or multiplied with each column here. Okay, according to whatever the operation is. If it's addition, then it's added to every column. If it's multiplication, then it's multiplied with every column. Okay, that's it regarding Python review. Now let's go back to our today's topic, which is about, actually the title of the topic, basic statistics. At the beginning, we will start by knowing about tabular data. So what is tabular data? So it's a data in a table format. So where we have number of records, here the rows are the records, okay? And each record has a number of features. Okay, these are the columns. The columns are the features. Okay, we call them features, we call them variables, fields. There are many names for them. Okay, and these are records, the rows, records or samples. Okay, so mostly we will be in this course, we'll be working with tabular data. So now if you look at these different fields, they come from different types. Okay, so this is not really precisely correct here, but we're going to stick with those definitions here for this course, because in fact, okay, let me explain first and then. So the field types, we have numerical data, okay, as the name indicates, okay. So they are numbers, okay, where the numerical value or the number has a meaning, okay. That is the first type, okay. Like for example, a value of 10 in the second row implies corresponding faculty has 10 years of experience. So there's a meaning for that numeric value, okay? There's also the second type, which is the categorical data, okay? It's non-numerical field, okay? So like, for example, here, this is it. This is of type categorical. There are different categories here, okay? So it's not numeric, but okay. So here is the point. So categorical data can be represented using numeric values, but just for representation, for identification. Those numerical values are given for convenience or for identification, okay? So, for example, like here, you can give different numbers to these, and we'll see a more clear example actually after this. For example, here, student ID. Student ID is a number you give to every student. It's not to give more value to one student over the other. It's just to identify different students. So a higher number doesn't mean like better or something like that, okay? So they are just for identification. So yeah, for the categorical data, I can use numeric, but like for example, yes and no. Okay, if I have a field with like values that are, do we have yes and yeah here, yes and no. Okay, this is categorical field, but I can still replace yes with one and no with zero. This is just to identify that this is yes and that's no. It's not meant to give the like a specific value. So also categorical, we have also another category of categorical data, which is ordinal data. Ordinal, it's a categorical field, but comes with an order. There is an order. For example, here, assignment, medium, high, low. Okay. So there is an order here. Okay. So here the number of assignments is low, then like medium is higher than low and high is higher than medium. Okay. And here, if you look at the GPA here, okay. So A plus is better than A or higher than A, and then A is higher than B plus and B plus higher than B. Okay, so yeah, so there is an order here. In fact, this is like I would say, like in general, we can say like nominal can be actually numeric or non-numeric. Okay, so you can say, for example, nominal data is where there is no there is no order. Like for example, for non-numeric, you can say the eye color, for example, blue or black or whatever. Okay, and you can also use it for numeric data where the number is just for convenience. For example, zip code, student ID. Okay, so it can be numeric and non-numeric. Okay, and ordinal data as well. Okay, so you can actually have numeric order. Okay, but that or so only the order has meaning there. So you order things, for example, you give 0, 1, 2, 3 to different choices just to order them. So the step size is not like a difference. It's not about like making differences, just about making orders. So you can have ordinal data that is numeric and categorical. But we, as the note mentioned here, let me read it first. Nominal data should not be considered as numeric data. As I said, that's debatable. Okay, generally categorical and nominal data are synonym. Okay, but in this course we restrict the definition of nominal data to numeric representation for convenience. Okay, so that's what we're gonna stick with here. Okay, it's not numeric in the sense that it gives value, but I still can use that what I said when I said debatable. It's not a numeric in the sense that it gives value, but it still can be represented using numbers. Okay, hopefully I clarified these things here. Okay, now we come to the different kind of variables. Okay, as I said, these columns, okay, can be named features, variables, fields. Okay, so we have different types of variables. We have independent variables, as the name indicates. They are independent. They are not affected by other variables. Okay. And we also give them all these names: attribute, control, explanatory, regressor, input, predictor, observe it, because that's what we observe. That's usually our input. And we want to compute the dependent variable based on our input or independent variable, set of independent variables. Feature, field, etc. Okay, and there's the dependent variable. Okay, that's the variable that depends on the other variables. Okay, so we also it's also known as the predicted, explained, target, response, output, label. Okay, in the context of classification, we call it label because in when we're building a model for a classification problem, then the model we are constructing is a model that takes a certain record and label it. This is belong to which class. So in the context of classification, it's called label. And there are auxiliary variables. These variables are not meant to be involved in any kind of computations or like so usually our target variable doesn't depend on them. They are just there for identification. As I said, they add like they provide meta information about our data. Okay, so yeah, these are the three types of the variables. For example, if you look here, Okay, let's identify. So identify all the variables, fields, and then identify their types. If we look into this student ID, for example, it's an auxiliary variable. Okay. So, and also it's nominal. Okay. Because the numbers are here are for convenience. Okay. As you can see, it's nominal here. Okay. The number is just given for identification. Okay. Score is numerical. Subject is categorical, as we can see. GPA is numerical. Honor is what? 0 and 1. Think of it as yes or no, honored or not. Okay. So this is nominal. Okay. So this is numeric, categorical, numeric, and honor is nominal. Okay. This is nominal. And grade is ordinal. There's an order here. Okay. There's an order. Okay. Yeah. So yeah, you can think of this as the dependent variable. This is the one we're trying to predict from the others. Okay. Yes. So now we come to frequency distribution. Frequency distribution is a graph showing how many times each value occur in a variable. Okay. So there are different ways and there are different tools and graphs in order to represent the frequency of different values or categories in data. So we're going to start with histogram. Okay. Histogram plots values of observation on one of the axes. Typically, we use x-axis, but you can use y-axis. Okay, so when you use x-axis, then you will have vertical bars, and when you use y-axis, you will have horizontal bars. Where if we're talking about x-axis, the height of every bar represents like the frequency of the occurrence of that specific variable or field or that specific value. Okay, not variable. Okay. Uh, the value can be ordered. Okay. Okay. So plot perpendicular bars to the above x-axis. The height of the bar shows how many times each value occurred in a data set. For example, here, okay, we have this field subject. Okay. This is our field subject, and subject can take one of these values: math, physics, and I think there's chemistry. Okay, there are three choices or three categories. It's a categorical field here. Okay, so looking into this now, if we wanna plot the histogram, the first thing we do, let me run this video again from the beginning. You see what's happening here. So we count how many times math has occurred. Okay, and that's the frequency of math. It's equal to 9. And then we do the same for the other two subjects. Okay. Okay, physics 13 and chemistry. It's taking time. Okay, chemistry is 3. So now we will have 3 bars. Okay, one for math, one for physics, and one for chemistry. And the height represents the number of occurrences. Physics has occurred the most. That's why this bar is the highest here. Okay, we call this the mode, and we're going to come to that later on. That's the histogram for a categorical variable. Okay, now what about numeric data? Okay, in numeric data we have one difference here. So we cannot have a bar for every uh, number because there is infinite numbers, right? So then how we play around this, we actually create bins or buckets. Okay, so we find the minimum in our data, the maximum, and the distance, this segment between the minimum and the maximum, we divide it into bins, and then we plot the histogram of these bins. So for a specific bin, if any number in that bin in this range has occurred, we will add it to the count of this bin. Okay, that contributes to the height of this bin. So here we have, let's run this example here. So we have these numbers, okay? Seems to like the minimum is equal to I think 70 or 71, and the maximum is equal, yeah, here, the minimum is equal to 71 and the maximum is equal to 100. So we're going to start from 71 to 100, and we are dividing this into bins. Every bin, so here, the first bin is from 71 to 80, second bin is from 81 to 90, and third bin is from 91 to 100. Okay, so now the occurrence of this is equal to 8. Okay, so like between 71 and 80, if we encounter any number there, then that will contribute to the number of occurrence for that bin. For the second bin, 12. For the third bin is equal to 5. Okay, and then we plot the histogram. Okay, so this is not a categorical data, so this is continuous range. So the bars will be touching each other. Okay, as we can see here. So most of the numbers are in this bin, okay, or this bin is has the highest frequency. Okay. There's also pie chart, okay. It extends the visualization offered by histogram. Okay, it's usually used for categorical data, and it plots the proportion or the percentage. Okay, it's not the exact the count or the number of occurrences, the percentage. Okay. The idea is to represent the proportion as the proportions as the sectors of a circle. So each one, how much you take from that circle, that depends on the percentage. Okay. Well, the length of the arc represents the proportion. Okay. Let's look at it here visually. Okay. So when we depict on the chart will be a circle. Otherwise, will be, yeah. If we have all of them, then it will be a complete circle. If we just focus in a partial set, then it will not be a complete circle. So here it is. So it's the same example we had for the histogram. We're gonna use a pie chart for it. Okay. So we have the number of occurrence for math, that's equal to 9, and we will compute the percentage or the proportion. Start with the like how many times each one has occurred. Physics 13. Okay. And chemistry equal to 3, right? So then these are, what is the total? The total is the sum of all of these. And then here, the sum is equal to 25. Here, the percentage for this is 36. You just divide the number of occurrence for that by the total. So 36 for that, for math, 12% for chemistry, and 52% for the physics. That's it. Okay. So you can clearly see like here, physics has the highest frequency, and yeah, and the highest proportion as well. Okay. Uh, yes. I think before we will stop here for today. Next time we start with the hands-on. Thanks for watching.